Welcome to Causal Chemistry online classes. In previous class, we had to discuss the rate of reaction for enzyme catalysis and what is Michaelis Menton constant. We have to discuss. We had discussed in previous class. Now, now we have to discuss what enzyme catalysis equation. Enzyme catalysis. Enzyme catalysis. In this, at high concentration of the substrate and low concentration of the substrate and intermediate concentration of the substrate, then what is the order of the reaction? Okay, here enzyme catalysis, the final equation is very important. Okay, what is the rate of reaction for enzyme catalysis is nothing but mu is equal to K1, mu is equal to K2 into E naught to substrate by Km plus S. This is the equation for what? Equation for what? Rate of reaction or velocity of the reaction for enzyme catalysis. Here Km is equal to what? Km is nothing but Km is equal to Michaelis Menton Michaelis Menton constant is nothing but Km is equal to what? K2 into K inverse by K1 into K1. Okay, Michaelis Menton constant. Here we have to discuss three different cases. First one is at high concentration, second one is at low concentration, and third one is intermediate concentration of the substrate. Okay, at high concentration of the substrate, at high concentration of substrate. Here the rate of reaction is equal to mu is equal to what? Mu is equal to the rate of reaction or velocity of the reaction. Mu is equal to what? K2 into E naught into substrate by Km plus S. This is the rate of reaction or velocity of the reaction for enzyme catalysis. Here at high concentration of the substrate means substrate concentration is greater than Km, or in other words Km is less than what? Substrate concentration. Okay, means here Km plus S is equal to what? Km plus S is equal to, means here Km is negligible, very small, negligible, and then Km plus substrate concentration is equal to substrate concentration only. Okay, then we have to negligible Km. Here mu is equal to what? K2 into E naught into substrate by what? Here Km is negligible, then substrate concentration. Then what happens? Substrate is cancelled. Then mu is equal to K2 into E naught. Nu is equal to K2 into E naught. Means here at high concentration of the substrate, the rate or velocity of the reaction K2 into E naught. Means here enzyme catalytic efficiency is maximum. Here the catalytic efficiency of enzyme is maximum. Catalytic efficiency of enzyme is maximum rate. Okay, here E naught it depends upon initial concentration of the enzyme. That's why catalytic efficiency of the enzyme is more or maximum. Then Nu is equal to what? K2 into E naught at high concentration. But here the rate is maximum, means K2 into E naught is written as mu maximum. Okay, when Km plus S is equal to S, Km plus S is equal to S. Okay, then the rate of reaction, this K2 into E naught is substituted in this equation. Then mu is equal to K2 into E naught is nothing but K2 into E naught is nothing but mu maximum into substrate by Km plus S is equal to what? S. Then mu is equal to mu maximum. Okay, mu is equal to mu maximum, or mu is equal to K2 into mu is equal to mu maximum into S by Km plus S. Okay, this Km plus S is nothing but S. Here mu by mu maximum is equal to substrate concentration by substrate concentration. Means here the fraction of catalytic active sites occupied by the enzyme, mu by mu maximum is nothing but fraction of active catalytic sites occupied by the enzyme. Fraction of active catalytic sites occupied by the enzyme, mu by mu maximum. Then mu is equal to mu maximum. This is at high concentration of the substrate. Mu is equal to mu maximum. And here, what is the order of the reaction? At high concentration? Means here zero order reaction. It is not depends upon. Mu is equal to K2 into E naught. Means it is a zero order reaction. zero order reaction at high concentration of the substrate. Means it is does not depends upon substrate concentration. Means the rate of reaction at high concentration is equal to what? The rate of reaction, the order of reaction. Here mu is equal to K2 into E naught. Means here mu is directly proportional to what? Substrate concentration is substrate concentration. Here no substrate concentration means here zero. Okay, means it is a zero order reaction. Zero order reaction at high concentration of the substrate. Okay, two things are very important. At high concentration of the substrate, mu is equal to mu maximum, and it is a zero order reaction. Okay, and next one is at low concentration of the enzyme substrate. At low concentration of the enzyme substrate. At low concentration of and low concentration of substrate. At low concentration of substrate. Here rate of reaction or velocity of the reaction K2 into E naught into substrate by Km plus S. Here at low concentration of the substrate means Km is greater than substrate, or substrate concentration is less than Km. Then Km plus S is equal to what? Km plus S is equal to what? Km. Then we have to write mu is equal to K2 into E naught into substrate by Km. Here the rate of reaction is depends upon substrate. Means the order of the reaction is nothing but order of the reaction is what? Means rate is directly proportional to concentration of the substrate. Means it is a first order reaction. It is a first order reaction at low concentration of the substrate. First order reaction. Okay, then next one is at intermediate concentration of the substrate. At intermediate concentration of substrate. At intermediate concentration of the substrate is nothing but 50% of the rate. Means mu maximum is equal to mu maximum by 2. Maximum rate means 100%, but here 50%. Intermediate means half of the rate of reaction. Means mu is equal to here mu is equal to mu maximum by 2. Mu maximum by 2. Then the rate of reaction mu is equal to what? Here mu maximum means K2 into E naught is nothing but mu maximum. Okay, mu maximum into substrate by Km plus S. Km plus S. Here mu is equal to what? Mu maximum by 2. Mu maximum by 2 is equal to mu maximum into substrate by Km plus S. Then mu maximum is cancelled. 2 into substrate concentration is equal to what? Km plus S. Here 2 into substrate concentration minus this one is minus is equal to Km. Is nothing but substrate concentration is equal to Km. Okay. Here at intermediate concentration of the enzyme. Intermediate concentration of the enzyme. Intermediate concentration of the substrate. Substrate concentration is equal to Km. Okay. This is very important. Okay. At high concentration, mu is equal to mu maximum and zero order reaction. At low concentration, first order reaction. But here at intermediate concentration, it is a substrate concentration is equal to Km. Okay. The order is in between 0 and order of the reaction is what? 0 and 1. In between 0 and 1 means less than 1. Okay. Intermediate concentration means at high concentration 0 order, at low concentration first order, at intermediate concentration means in between high and low means less than 1. The order of the reaction is less than 1. Okay. In graphical point of view, the concentration of substrate at low and high in the intermediate is represented as follows. Here the rate of reaction mu, this one is substrate concentration. Then the graph like this way. Here this one is belongs to high concentration of substrate. High concentration of substrate means nothing but what we had to discuss already. High concentration of substrate nothing but zero order reaction. Zero order reaction. This one is mu. First order reaction at low concentration of substrate. First order reaction. This is the intermediate concentration is nothing but mu is equal to what? Mu maximum by 2. Here S is equal to what? Km. Intermediate concentration S is equal to Km. This is mu maximum. Mu maximum means at high concentration of the substrate. Mu maximum zero order high concentration of the substrate. Mu maximum by 2 means here S is equal to Km intermediate concentration at low concentration first order reaction. This is the overall about enzyme catalysis. Okay, thank you.